You know the incidents in Nagasaki and Hiroshima, but how did it really work? Hi, I'm Federica, and today we're going to look at how two very important and famous bombs were made and how they work. Okay, so let's start with the fission bomb type 1. I want to first start saying that there are mainly two types of bombs. There's the fusion and the fission. The ones we're going to talk about today are the fission bombs. There are two types of bombs. Let's start with fission bomb type 1. So this bomb is mainly the one with the most simple structure. So it has this supercritical mass. It's kind of a sphere. It has this supercritical mass, which is contained as a sphere, which is mainly made of uranium-235 particles. It's used uranium-235 as it has very heavy particles. So how this is there's the supercritical mass, and then around it there's a neutron mirror, which keeps the neutrons inside and doesn't let them out. The neutrons are mostly needed for the chain reaction, which we're gonna see later. So when assembled, this sphere is divided in two. So we have one half and we have another half. When we assemble it, this sphere these two halves are not touching, and apart from our other halves, we have this explosive. We have just a simple explosive, which is the one that's gonna activate our starting explosion. So we have this little explosive. Then when it goes off, it creates a little explosion, but big enough to push the two halves together. And when they combine, they create the explosion we know, of the atomic bomb. These two spheres actually have a name. The whole thing is called the supercritical mass, and the two halves are called the subcritical mass. Why does it have this name? So the supercritical mass, when we imagine it as the value of these two halves, let's say is 4.5. So let's give a value to these two mass, which is 4.5. When they collide or they get together, so both values of the two halves is 4.5 of both of them, and then when they collide, they create 9, which in this case is the max value this mass can reach, and once it reaches that max, it then explodes. So inside the sphere, what happens is this chain reaction, which we're gonna see more in details more later. But this chain reaction happens in both our bombs, and it's a very important thing that then happens when, in this case, when these two halves merge together. But you're gonna see this chain reaction also in the other bomb. Now let's talk about the fission bomb type 2. So like the other one, which could also be called as the uranium bomb, as the main element of that bomb was uranium, more specific uranium-235. This could also be called plutonium bomb, as it has a more complicated structure and complex working. So while the other one is usually assembled as a cylinder, or like a solid cylinder, this is more of a sphere, and its main element is plutonium, while in the other one it was uranium. So it's how this bomb is made is at the center it has a little sphere of beryllium, and then it's filled with plutonium. And one thing they have in common is that after, so we have the beryllium, the plutonium, and then after the plutonium we have a neutron mirror, which keeps the neutrons from going out, and it just keeps them in. And this is actually very important and very essential, especially in this bomb, as the neutrons are very important for the chain reaction and the size of the explosion this bomb is going to have. Okay, so the majority is filled with plutonium, as you said, and then and then what it has is on the outside is actually covered in a layer of explosives. So why why do we use beryllium for this bomb? So beryllium is almost a reflector which directs the neutrons back away from the center, and especially it generates more neutrons, which are going to be then needed for the chain reaction, which we're going to see later. So the chain reaction is essentially mostly how just the bomb works. Without this chain reaction, the bomb wouldn't have as an effect as it would have without it. One particular thing about this bomb is that the plutonium actually acts as an explosive itself. So what actually activates this bomb is the explosive present on the outside of the bomb. So while these these explosives have a little explosion, they're big enough to send a wave inside, so back to the center, and the plutonium with the waves and the neutrons actually then explodes, and thanks to then the chain reaction, the plutonium from exploding thanks to the waves of the outer explosives, thanks to the chain reaction, it always becomes bigger and bigger and bigger. So especially in this bomb, the chain reaction is very, very important. So as I said, the chain reaction creates then the major explosion, and the chain reaction happens in the plutonium pit and starts near the beryllium center. Why plutonium? So as well as the uranium bomb, this also can be called the plutonium bomb, as the main and more fundamental element of this is in fact the plutonium present inside majority of the bomb, and yeah. So apart from the plutonium, one essential thing is also the happening of the chain reaction inside the bomb. What actually is this chain reaction I'm talking about? So when a nucleon of plutonium or uranium-235, actually it's used uranium-235 as it is more fissionable, which means it's more unstable than normal uranium, which has more reaction. So when these nucleons get slammed by a neutron, it divides into two, and both of these release some energy. This energy was the energy that was needed to hold these two parts together, and then when they're divided, this energy gets released. Okay, so at that moment when these nucleons get hit by neutrons, so when they get hit, they shine some light, and also in the meanwhile, other than neutrons are hit by other nucleons and then dividing and creating two, and they're then hit by other and they divide into two, and then they're hit again and divided, and it goes on as a chain, and so it goes on and goes on forever. Well, not forever, but it then continues to go on. That's why it's called a chain reaction. Yeah, and this chain reaction, when also the light, when so we said that when one gets hit, it shines some light, and that only nucleon, when the only nucleon with so many other nucleons, when they all shine light, it then becomes always bigger and bigger. And this chain, if we start with one, and then it divides into two, and then into four, and then it just continues on, the explosion becomes from one, it becomes bigger and bigger and bigger. So that's why it's called a chain reaction, and that's why it's super important in these bombs, as this chain reaction almost defines the final size of these bombs. So it's very, very important. Then we could also go back in 1942, from where the Manhattan Project started, and which is what started all of these bombs and how they work and the construction of them. And so this is it for this video, but actually if you want me to do a video more about the history of this physics behind it, so the Manhattan Project and specifically the role of Oppenheimer of Robert Jameson in Oppenheimer in this project, and what he did regarding these bombs, you can write it below in the comments, and if you want, I'll do a whole video related to the history of the Manhattan Project and of these bombs, and of course of Oppenheimer. I hope you liked this, you enjoyed it, because when I started learning about this, I absolutely enjoyed learning about these bombs. If you also did, great, go watch my other videos, and for today it's all.